Okay, here we have the notes for section 5.1, bisectors, medians, and altitudes. So there's our main ideas, and then a whole lot of vocab words. So I'll try to get through them all. So the first one we have here is a perpendicular bisector of a side of a triangle's aligned segment array that passes through the midpoint of the side and is perpendicular to that side. So, for example, if I just draw some nice triangle in here, if I want to make a perpendicular bisector to this side, it's going to go through, cut those two parts equal, and be perpendicular. And there's one of those for each side. So that would be congruent to that. And then the last one, 3, 1, 2, 3. Now they do meet at a point here. That point is called the circumcenter. So here's just some properties about perpendicular bisectors. So the first one is if you have a bisector, every point on the bisector is equidistant from the endpoints. Or the reverse is, if you know your point is equidistant from the endpoints, it must be on the perpendicular bisector. So here, that's what we just talked about, the circumcenter. So 3 lines that meet are called concurrent. Where they meet is the point of concurrency. So for the perpendicular bisectors, that's called the circumcenter. So here, if you have the circumcenter, so what this one says is that the circumcenter is equidistant from each of the vertices. So J is the circumcenter here, so BJ, AJ, and CJ are all the same line. Okay, we're not going to worry about this proof. We will do proofs later. So theorems here, 4 and 5. If you have an angle bisector, that means the angle bisector is equidistant from either side of the triangle. So for any point along the bisector, it's the same distance to the two sides. Or the reverse of that's true. If you know your point is equidistant from the sides, it must be on the bisector, which is kind of like the perpendicular bisector one. All right. So angle bisectors meet at a point called the incenter. And since they're bisectors, they are then equidistant from each of the sides. So the incenter is the same distance. So K to R, K to P, and K to Q are all the same length if these rays are bisectors. So the next one we've got is the median. So this one doesn't have a picture, so I'll draw one. So medians go from the vertex to the midpoint of the other side. So something like, that's really terrible. Let's try that again. We'll draw a more exaggerated one. So there's a median, compare to that. There's a median, compare to that. And there's the median, 1, 2, 3, 1, 2, 3, compare to that. That point is called, whoops, the centroid. Now the centroid has a useful property. The centroid is 2/3 of the distance along the median. So in this case, A to L is 2/3 of the distance from A to E. The other way to think about it is that the corner to the middle is twice the middle to the edge. So this is equal to 2 times that. Also, if you know the whole length, what's right over here? So AL is 2/3 the full length, which means that LE is 1/3 is the other part. So even though I don't write it here, LE is 1/3 of AE, and you can do that for all the ones. So like DL is 1/3 of DC, LF is 1/3 of BF. Okay, example 2 here. So this is going to use those tricks. Now, so here's X. So this section here, so DA is twice AT. So I can set them as equations. So 6 is equal to 2 times AT. So 6 is equal to 4x minus 10. 16 is equal to 4x. X is 4. And then you repeat that process for all of them. So for Y is equal to 2 times 2.9, which is 5.8. So corner to middle is equal to twice middle to edge. And then for Z, where's Z? Corner to middle is equal to twice middle to edge. So 4.6 is 8Z. So Z, that's not going to go in evenly. 4.6 divided by 8. is about 5.8 or 0.58. So there you go. The last ones you have are referred to as altitudes. So an altitude goes from a vertex and it runs perpendicular to connect to the opposite side. It's called the orthocenter where they meet. Now you can have two kind of different triangles. So here, I'm going to cue it. So like that's an altitude. That's an altitude, and that's an altitude. So they meet in the inside. But if you have an obtuse triangle, you have to extend the side out. So like that would be the altitude for that corner. This corner, that would be the altitude. And then that would be the altitude. So down here, the last one here is just a summary. So the name of the things, perpendicular bisectors meet at the circumcenter. Angle bisectors meet at the incenter. Medians meet at the centroid. Altitudes meet at the orthocenter. That's the end of the section.